All right, in this video, I'm going to show this relationship where the sum from I equals 1 to n of xi minus x bar times xi is equal to the product of xi minus x bar times xi minus x bar, right? And this is equal to the sum of squares for x, right? So sometimes you'll see this written as sxx. Right. So this relationship is a relationship that you will use when you are deriving various proofs for the least squares estimators in a simple linear regression. Okay, so it's important to understand why is this equality true. And so I'm going to go ahead and let's show this here. I'm going to go ahead and start with the right-hand side of this equality, and then we'll show it equals to the left-hand side of the equality. So first thing I'm going to do is I'm going to take my sum from I equals 1 to n, right? And first thing I'm going to do is I'm going to multiply xi minus x bar. I'm going to multiply it by that xi, right? So basically, I'm going to break up this difference, right? So first I'm going to multiply by that xi, and then I'm going to minus, and I'm going to have xi minus x bar, and I'm going to multiply it by this x bar here, right? So you can see, what I've done is I basically have distributed just this half of the product. Okay. All right. So then now once I'm here, this is like a sum of this is the sum of a difference, right? So I can make this the sum of each piece. So xi equals to n, from I equals 1 to n, and then xi minus x bar times xi, okay? And then I have minus the sum from I equals 1 to n of xi minus x bar times x bar. Okay. So now once I'm here, I see, okay, so I'm starting to have this is the same as this, right? So I've almost shown this equality is true, except I still have this piece out back. So what's going on with this piece out back? So this must be equal to 0. So let's go ahead and keep writing. Let's go ahead and keep going here. So I still have the sum from I equals 1 to n of xi minus x bar, xi. Okay, so minus. So I can take this x bar. It does not involve an I, so it can be pulled out of the sum. So I have x bar being pulled out. It's like a constant because it does not have I in it. Okay. So now I'm not going to keep, so this stays the same here. So I'm not going to keep writing it for every step. But now I have, again, a sum of a difference. So I can write this as the sum from I equals 1 to n of xi, okay, minus from I equals 1 to n of x bar. Okay. Now, once again, this does not involve an I, but it's being summed over I times, right? So this piece here, the front piece stays the same, and I have x bar out front, right? I'll leave this alone from I equals 1 to n of xi, and then this is n x bars, right? I'm summing the same number n times, so there's n of them. N times x bar. All right. So now, what is n times x bar? Right? Remember, what is x bar? X bar is the sample mean from I equals 1 to n of xi divided by n. Right? So I can use algebra, multiply both sides by n. Right? And I will have n x bar equals the sum from I equals 1 to n of xi. Okay, so let's use this, and let's go ahead and plug it in for n times x bar. So I have x bars hanging out in the front, and I have the sum from I equals 1 to n of xi minus the sum from I equals 1 to n of xi, right? Because this n times x bar is equal to this sum. All right. So once you're there, you can see, okay, so I have the same thing minus the same thing. So this whole is going to be x bar times 0. So we have minus x bar times 0, right? And if I scroll up, we see that we have what was here was from the sum from I equals 1 to n of xi minus x bar times xi, right? So now I've shown, since this is minus 0 basically, this back piece just goes away, right? Now we've shown that sxx is equal to the sum from I equals 1 to n of xi minus x bar times xi.